Hi everyone, let's start our lecture with Newton's first law. Before going further with Newton's first law, let's define force. Forces are the cause of any change in object velocity, and also a force is the cause of acceleration. Anyone knows the unit of force? Yes, George? Exactly. So the unit of force is Newton in SI units, and what exactly? It's pounds in US units. One more thing we need to discuss about force is a vector quantity. Anyone knows what's the meaning of a vector quantity? Sally? Exactly. So a vector quantity, we need actually two things: magnitude and direction. Magnitude, like when you push hard, push gently, this is the magnitude actually. And the direction, when you force directed like to the left, to the right, south, north, etc. This is the direction. Forces can actually be categorized into two main types: contact force, like the one you can see in this one right here. Okay, there's a physical contact, like this case here when you stretch a spring or compress a spring. Like this one here, when this lady is like pulling the cart with her child. When you kick a ball, all these are examples of contact force. Now the other types of forces is field forces, when there's no physical contact, like the one here. It's a gravitational force. The one exists between the moon and the earth, the planets, etc. Now we have also electric force, like the one between positive and negative charges, and we have magnetic forces, like the between the magnet and some piece of iron material. Any kind of push or pull is actually a force, like in these cases here. So forces actually is a kind of push or pull. Either one of these is a force. One last concept we need to focus on is the net force. So sum of all forces here, which called the net force. You can think of different examples, like when you just push the spray button or when you just turn the light on and off. All these are kind of pull or push forces. Before starting with Newton's first law, let's have this model. In this model, we can see that this fire truck, the top one here, is not moving. It's stationary. I need someone to tell me exactly what's going to happen for this truck after 1 hour from now. Sally? Exactly. This car will remain stationary. It will remain stationary forever. Now, if we move to the next model, this one here, and if we give this car a small push, small initial velocity. Now, I need someone to expect what's going to happen if we give this car an initial velocity. Julie? So you expect that this car will move with constant velocity. Okay, let's see. Exactly. So the car is actually moving with constant velocity. In this case, it's 1 meter per second. And the net force here is equal to 0. Okay, I can see you have a question. Yes? So Amanda is asking, how come this car is moving and the net force equal to 0? Anyone can answer this? Julie? Okay, yes, we're actually focusing on the velocity here in this case. And it doesn't matter actually the net force equal to 0 as long as we have a velocity, initial velocity here, and this velocity is constant all the way. So my point here is the car will remain moving forever. Now let's modify the model, the previous model, a little bit and see what's going to happen in this situation. Now this car initially at rest. What's going to happen if we give this car a driving force equal to 1.9 newtons? Any expectations? John? Okay, you expect that this car will move with constant velocity or it will accelerate? Perfect. We're expecting that this car will changing its velocity from 0 to some value, and since we have like change in velocity, this car will actually accelerating. Let's see. Starting from rest 0, and you see here it's the velocity actually is changing, which means this car is accelerating. Perfect. So based on the models we just saw a few minutes ago, I need someone to summarize the whole situation. Okay, Sarah? That's exactly Newton's first law. An object at rest remains at rest, and an object in motion continues in motion with constant velocity. For instance, this real-life situation, like traffic light here, will remain this situation forever unless there is some external agent will modify its status. So this light traffic here, if there is some windy day, will move this light traffic, or one of the cables broken, and in this case the situation will be different. Otherwise this light traffic will remain this way forever. I need you to pick up your clicker and answer this multiple choice question. A book is lying at rest on a table. The book will remain there at rest because, here's the choices. Okay, think of the answer and remember Newton's first law. Okay, I'll give you a couple of minutes to answer this one here. Based on your answers, I can tell that most of you answered this one right here, because sum of all forces, or the net force, equal to 0, and for that reason the object will remain stationary because it's originally lying at rest. Now I want you to use your clicker and answer this following question, but this time you can discuss the answer choices with your classmate who are sitting next to you. So we have here a situation. Consider a cart on a horizontal frictionless table. Once the cart has been given a push and released, and this is very important here, it's given a push and released, so the effect is no longer affecting the cart. What will happen to the cart? Perfect. Based on your choices, I can tell that all of you answered this one right here, because Based on Newton's first law, a moving object with constant velocity will remain moving. As homework for the next lecture, I needed to think of this situation, although we didn't discuss everything in here, but I needed to think of this, and our next lecture will start with this situation. So your little sister wants you to give her a ride on her sled. On a level ground, what is the easiest way to accomplish this? Whether you push from behind, like this one here, or pull her from front, both are equivalent. It's impossible to move the sled. Tell her to get out and walk. By the way, I wouldn't choose this option here. So think of this for the next lecture. For the next week project, observe and document 2 real-life situations showing Newton's first law. Describe the initial state of motion, identify the forces, and explain how the law applies. You can focus on objects at rest, in uniform motion, or changing their motion. Use illustrations if possible. And by the way, you can submit your project by the end of next week on the Blackboard. At the end, if you have questions, you can contact me during my office hours or reach me anytime via email, Google Classroom, Moodle, or Blackboard. Thank you and see you next time.